What's up guys, my name is Bryant Warrick Cai and today I am going to explain to you how to do review exercise 7 on new Syllabus Mathematics 7th edition on page 242, number 5 and 7. So let's start from question 5. Question number 5 says, ABCT is a triangular pyramid with ABC as its base and BT as its height. It is given that AC is 24 meters, BT is 12 meters, angle TAB is 35 degrees, and angle ABC is 90 degrees. Find the length of AB, the length of BC, and the angle of depression of C from T. So first, we have to find the length of AB. In order to find the length of AB, we have to use the triangle ABT. Now, triangle ABT is a right-angled triangle because AB is a base and BT is already a height, so it is vertical. So, because it is a right angle triangle, we can use a trigonometrical ratio. We have to do tan 35 equals to 12 over AB. AB will be equal to 17.1 meter. However, we must also save 17.14 meter for the next step in order to avoid rounding errors. Next, we are going to find the length of BC. Now, we can also see that ABC is a right angle triangle since we know that the angle ABC is 90 degrees. It means that we can use the Pythagorean theorem to find BC since we have known the length of AB from the previous step. To do this, we can do 24 square equals 17.14 square, which is the length of AB plus BC square. BC will be equal to 16.8 meters. For the last question, have to find the angle of depression of C from T. So the first step that we need to do is draw an imaginary line. I'm going to name the end of the imaginary line D. So the angle of depression of C from T is basically the angle DTC. DTC and BCT are alternate angles, so their angles are the same. So now we have found the length of the line BC. That means we can find the angle BCT using tangent. Tangent BCT equals to 12 over 16.8, which is the length that we found. BCT is then equals to 35.5 degrees. So now I'm going to explain question number 7. The question is, 3 points A, B, and C lie on a horizontal ground. T is the top of a vertical tower standing on A. The bearings of B and C from A are 135 degrees and 225 degrees respectively, and the bearing of C from B is 250 degrees. If the distance between B and C is 50 meters and the angle of elevation of T from B is 35 degrees, calculate the height of the tower and the angle of elevation of T from C. So first, we are going to plot all the known angles. We know that the bearing of B from A is 135 degrees, so this angle is definitely 135 degrees. We also know that the bearing of C from T is 225 degrees, so it means we can find the angle BAC. We can subtract 135 from the total angle, which is 225 degrees, and we'll get a 90 degrees. We also know that CAT and BAT are both 90 degree because CA and AB are points on ground and AT is a vertical line. We also know that the bearing of C from B is 250 degrees, so we are going to draw an imaginary line, and this angle is 250 degrees. Now that we know that BAT is 135 degrees, this angle can be known because TA and the imaginary line are parallel, so the angle of the new line is 180 minus 135, which is 45 degrees. With this, we can now find the angle of ABC, which is 360 minus 45 minus 250, which is equal to 65 degrees. And we can find the length of AB, which is cos 65 equals to AB over 50. And it is equal to 21.13 meters. The length of AT can now be found using tangent 35 equals to AT over 21.13, which results in AT being 14.8 meters. With Pythagoras theorem, AC equals to 45.32 meters. And ACT can be found using tangent, which results in 18.1 degrees. Thanks for watching, and be sure to like, comment, and subscribe to my channel. And feel free to ask in the comments if you have any questions. Thanks for watching and stay safe.